Nearly everything in this universe is made up of matter. You, me, your dog, a cat, everything you can think of is made up of matter. In other words, they are made up of the elementary particles, the protons and the electrons. But for every particle, there exists an equal but opposite antiparticle. These particles have the same mass and same everything, except for they have opposite charges. Like an atom is made up of protons and electrons, antiatoms are made up of antiprotons and positrons. Seems like scientists were short of names. If we take half kg of matter and half kg of antimatter and put them into a jar, both the particles will start annihilating each other, creating a lot of energy. But how much energy? The energy created will be 1500 times the energy of the Hiroshima bomb blast. Mind blowing, right? But how am I supposed to prove this to you? Remember this equation, E is equal to mc square. Here E stands for energy, m is for mass, and c is for speed of light squared, which is basically 9 followed by 16 zeros. According to this, mass is nothing but concentrated energy, which means under right conditions, mass can become energy and energy can become mass. It takes tons of chemical fuels to propel a rocket to space, costing about 200,000 to 300,000, considering it's only the cost of the fuel and other parts altogether cost a lot more. Using so much fuel increases the weight of the spaceship, therefore decreasing its speed. The most significant advantage of antimatter propulsion is that it increases the speed. A rocket carrying nuclear reactor would take almost 180 days to reach Mars, but a positron reactor can reduce the time by almost 130 days. Also, it will be much safer to launch. A nuclear reactor, if it explodes, could release harmful radioactive particles into the atmosphere, but the positron spacecraft would just release a flash of gamma rays if it explodes, and the gamma rays would be gone in an instant. According to NASA, just 10 milligrams of positrons are needed for a human mission to Mars. There's just a tiny problem. Due to the spectacular effect of matter on our antimatter, it is very difficult to preserve it. A rough estimate to produce just 10 milligrams of antimatter is about $250 million. This cost might seem high, but it has to be considered against the extra cost of launching a heavier chemical rocket or the cost to fuel it. And it is also reasonable to expect positron production cost to go down with more research. If this is so, perhaps the first human to reach Mars will arrive in a spaceship powered by the same source that fired spaceships across the universe in our science fiction dreams.